So that is your equation of the curve without the c. Get it? Okay. Can yeah, understand example 6. Example 6 very interesting. I don't know. Interesting because I find that it's like a differentiation problem. Because it begins with given that the rate of change of y. Yeah, so it's like differentiation problem. So be careful of such question. They open up like differentiation. So example 6, rate of change of y, but they're not asking you to find rate of change. So it's not differentiation. So not so much differentiation. So they say rate of change of y is dy dx, not dy dt, because they say with respect to x. So it's dy dx. Is inversely proportional. Do you still remember inversely proportional? In your EMAT?
No.
No, cannot. Must remember. Inversely proportional means you have this symbol. Engineer tell us what will happen. S cube. Okay, thumbs up. 1 over s cube. Inversely means 1 over whatever they are talking about. If they say directly, then it will be the fish symbol with s cube. It's a fish. This is called a fish symbol. In the math community, we love to call it fish symbol. Very interesting. Okay, it's a fish symbol. So this means dy dx equal to k of x over 3. Okay, the constant of proportionality k. So you have k over s cube. Then the question say, and when x equal to 2, the rate is 2. So this is the rate already. So you can say right? Because we have an unknown k, it will be good for us to resolve all these unknowns as soon as we can. We don't hold it there until the end. We cannot resolve the big problem. So now we have the k, right? We have the k unknown. Then we want to find out, is there a way that we can solve for the k as soon as we can before we move further? Okay, so here we can solve it first, then we solve it first. So k is 16. So your dy dx is equal to 16 over s cubed. So we have finished one section of the problem. Okay, now we are going to find equation connecting x and y. So we will think of it as a gradient function. We are going to find the equation of the curve. So here we're going to do the integration. We are reversing. We are trying to get rid of the gradient dy dx. So we integrate. Okay, I'm writing in different color because it's like another milestone. We are crossing another milestone. Okay, so we are doing another thing. So now we are integrating that function. Sorry, let's clear out this part. It's minus. Okay, so we integrate, we get 16 x negative 3 plus 1 over negative 3 plus 1 plus c. And we have another constant to worry about. Okay, so we need to find out what is this constant, c. Then how to find out? I put it here a bit. Then I just simplify a bit. this is 1. Negative 2 over s squared plus c. Okay, and the question tells us when s equal to 2.
What negative 2 though? Isn't it 4?
8. Sorry. Is it 8?
I thought it's negative 8.
8. Who say 4?
Oh.
Not Samantha. Samantha, I mute her. BB. Sorry, I'm tired. 8. 8. Correct. 8. I write 2. I don't know why I write 2. Yeah. Must be thinking of minus 3 plus 1. Then the 2 somehow comes into my mind. Yeah. So you have 8 over s squared with a negative sign plus c. So now s equal to 2, y equal to 3. So we sub in. The information. Then we get 3 equal to negative 8 over 4 plus c. So c will be equal to 5. Okay. Once your c is equal to 5, then we are done already. So the equation is equal to negative 8 over s squared plus 5. No need to make to the answer given, because the answer given in the note is just to make it no fraction. Yeah, that's all. Okay, so this is the answer. You can leave the answer in this way. Question on this. When you see an equation like this, what is in your mind? Do you think of this? Reciprocal square curve? Yeah, that kind of thing, because of this. Alright. Okay, anyway, let's look at example. We take a break. We take a little break. Read the question, take a break, read the question. Okay, read the question, then we will do the question. The answer wrong. No. Later we will fill up the answer there. I just want to ask you all, do you all put in the notes? Do you all like need the hard copy? Up to if let's say you really need a copy, right? Then I don't know what the center can do. I heard some students, they need the copy so much, then the center has to post to them, by mail. Yeah. Then but here is that if you have a phone, right, and your laptop, will be good. You can just get the soft copy in your phone, and then you can scroll and read the question. Yeah, something like that. Then you copy down your answers, then you can refer to the soft copy and read connect to the question and solution. Okay. Yeah. So read the example 7. You'll be good to draw some picture if you feel more secure. Yeah, can all of you okay? We look at the question. A container initially empty, so it's in the diagram here. Initially empty is filled with water. After 3 seconds, the depth of the water in the container is h. and the volume is V. And the equation is for V equal to H cubed plus H squared. So given that the rate of the depth of the water increases at this rate, find the rate of increase of the volume when t equal to 3. So what type of question is this? It looks like rate of change problem, right? Looks like rate of change problem. Because of this question, find the rate of increase of the volume. Yeah. You must be very firm with what you are reading. So this is integration chapter, but the question looks very differentiation. So here we will try to bring our knowledge of differentiation to find dV. Okay. So this is our question. Find dV dt. Okay. How to find? Form chain rule. It's a rate of change problem. Form a chain rule. Yeah. So form the chain rule. This will be our central expression. We cannot change this expression, which is the question. So dV dt. So we are going to form a chain rule around this dV dt. Okay. How to do it is we need another variable. What's the other variable? It's the h, right? I think you know it's a h. H is the other variable. So we are going to use the h to form a chain rule. Yeah, how to form? In this case, we will write dV dt as dV dh times dh dt. It depends on your chain rule and the situation. So your chain rule may be formed. In this case, we form with dV dt the subject. Sometimes the dV dt may not be the subject. So you have to form the correct chain rule. Okay, once you get it, then you try to assess the situation. What I have, what I don't have. Yeah. So do I have dVdh? Can find, right? No problem. We have this equation. We can find dVdh. So no problem. This one from okay, we can find this quantity. So we find it first. Then we find dVdh. So very simple. Do the easy thing first to get the easy marks. Not hero. In exam, we cannot be the hero. You have to get as much as we can. Then you can be the hero. Okay? So get this first, then we are done with this quantity. This one settled. Now, what is dH dt? They say something. dH dt, the depth of the water increases at the rate of 2t. So dH dt will be here. So dH dt is 2t. That's what the question says. So we follow. Now it seems like everything looks good. Is it or no? Is there anything missing that we... How come no integration? We are anticipating integration. There is lah. Okay, why? Because can you imagine? I write here. Here you see. Therefore, dV dt is equal to dV dh times dH dt. You see, I'm doing all this multiplication together. So where did I get it from? Okay, I get this quantity here. replace it. Then the other quantity is there. I also replace it. Okay, so they are all here. Get it? So far? Can, huh? Then we are given in the question, we are given t equal to 3. When t equal to 3, it seems like very good, but then you have a problem. Then what is h? When t equal to 3, what is h? Yeah, so this is a problem here. We need to find h. Get it? We need to find h, huh? Before we can find dv dt. So we go to the next part, huh? How to find h? How do we find h here? It's from this to find h. So from dh dt equal to 2t, then we get h, which is integration, reverse the gradient differentiation process. Okay, I pause here. This is the dh dt. Equal to 2t, we find h by integration. We reversing the differentiation process. So there we get t squared plus c. You do your integration, you get t squared plus c. Yeah, then what to do next? Find c. Okay, find c so that you can have complete information about the h. So how to find c? This part. A container initially empty is being filled with water. So since at the beginning there's no water because it's empty, it means the h is 0. No depth. No water, no height. So h is 0. Therefore, c is 0. Okay, because your c is 0, you see I'm writing everywhere. Okay, so since c is 0, I can have the equation of h. And then what happened? I can go back to the bottom part here. When t equal to 3, I can answer this question. What is my h? So when t equal to 3, my h will be 3 squared, which is 9. Okay, so when t equal to 3, h equal to 9. Then I can have my dv dt again. So this is my dv dt. I move back here to the board. So dv dt equal to 3/4 h squared plus h times 2t. Okay, yeah, then you'll get quite a big number lah, I think. Yeah, do you get this number? Okay, so this is cm per second. Yeah, so this answer is wrong. So far so good. You all still got the energy? Can, If okay, right, we move on a bit. All of you finished copying already? Sarah?
Yeah.
enter. Okay. Okay, this is the exercise. Part of this will be your homework. Okay, so your homework includes that differentiation and part of these questions here. We'll do some of these questions here to get ourselves familiarized. Then I will send the next part of integration to you. Okay, our lesson will not go to the next part. We just do some. Okay, so we look at our question. Okay, let's do this question. One. Okay, at least I'll try the differentiation, then I'll get familiar with integration problem. Not differentiation, integration problem. Yeah. Question one. So you read the question first. Okay, so your rate of change of the volume is given by this expression. There's a K constant. The container initially contains 3 cm³ of water. So we write the information down first. Rate of change of the volume is this. Okay. Initially, yeah. So this is the information. Then from the information, we are going to find the volume in terms of T. Okay, if the volume of water is 17 after 2 seconds. Again, to find the volume, given dV/dt, we are going to reverse the process of differentiation. So we do integration. Okay, very good. You all doing own stack, eating stack. Yeah, or lunch. Engineer, your one is a lunch. Okay, never mind. Let's look at this. dV/dt. Up to this point, can I check with you? Are you able to detect is we have to do integration at this point to find v? You have to do integration. Okay, from differentiation, you have to reverse the process. You have to do integration. No other way already. Okay, so here we have the v integrate. Try to integrate this expression. I still want to point out this k. This k is a constant. So when you integrate, you get kt. It's a result there. Yeah. Always when you see a constant, you integrate, you get a constant from the variable. Simplify it a bit, then we have 6 3 t square plus k t plus until here. Yes. 6 divided by 3.
6 divided.
Yeah.
6 divided by 3.
It's 2. Okay, good. To test whether you're alert or not. So nice. Okay. Okay, then after this, what to do? We have 2 unknowns, the k and the c. We need to find them. So we are going to find using this information. So sub 0, V equal to 3. Then we can find C. So we get C equal to 3. So we get the volume. Now we are going to find K. Okay, how to find K? To find K is you need another piece of information, which is this one. If the volume of the water is 17 cm cube after 2 seconds, yeah, that's the information, right? Very good. We can use it. So we yeah. Okay, I will shift it to below. Not much space. I shift it to below here. Okay, so V equal to 17, T equal to 2 into the formula, we get 17 equal to 2 of 2 cube, 2 square plus 2k plus 3. Then what is the k? Yeah, something like this. Okay, so k equal to 1. Once you get k equal to 1, finish already. You just subtract the k equal to 1 into the V, you get the answer already. Yeah, can? Next one, look at number 2. Okay, number 2. There are a few reasons why I want you to do all these questions. Here is because it's a new topic, so it's good to do them. We don't have a lot of examples to cover, so just do the questions. And another thing is online. Online, it will be difficult. I don't know. You see, you all seldom submit homework, not consistent. Yeah, so rather than wait for your homework, I would want to see how you do them. Okay, so let's look at number 2. Then get familiar with the topic. Okay, number 2. The curve has equation. It has a turning point. Find k. Okay, you try and see whether you can do this question. Think about how to do. Find k. Is it obvious to you, or is it what? This is a 2 marks question, I think. Then this will become about 4 marks. If you have the mark there, then easier to know how much work to be done. Cannot. Why is Amanda, your place so noisy one? Is it very noisy?
I don't know.
You can feel or not? Do you feel noisy?
No, I cannot.
Oh. The rest of us can, right? Can, Engineers, the fan very good. You must ask her where the parents buy, because not much sound. Then Sarah, your side quite windy. Sometimes got the wind blowing from your right side. Okay?
Yeah.
Right side. Yeah. Then Phoebe's the room look very cooling. Okay. Yeah. Let's look at number 2. No, I'm not I'm not very don't mind. I'm not looking at your background that much okay. Yeah, I still look, but I don't think about very deeply what is happening. Some people, they look at the house, they can tell the character of the person. Oh, this one I cannot. Okay. Yeah. Okay. The curve, part 1. You all manage to do it? Still doing? Can get k equal to 8. Samantha can or not? Samantha, are you doing, or like, don't know, looking?
I'm doing, Joe. Just cannot see me.
Oh, you know, I have a student. He's quite strategic. You know, he put the webcam facing his table, so that when he does his work, I can see what is he doing. Not exactly what is he doing. At least I see him holding a pen and then he's writing something. Yeah, so I find it not bad, this idea. Yeah. So we are talking about maybe next time in the future, there'll be every household, there'll be a room where it'll be filled with all webcam. Then the person can see your room and see what you're writing, see your face, everything, that type of thing. So you enter the room, you must be careful. Yeah. Okay. Part 1. Can you get go to 8? Sarah?
No, I got mixed up with C.
Okay. Phoebe?
No.
What? No, 2 marks. Turning point. A turning point. dy dx is 0. Yeah, it will mix with differentiation knowledge. Okay. Yeah, dy dx is 0. And this turning point occurs at this point, -2, -1. Okay. So in this case, therefore, 0 equal to 4, -2 plus k. So k equal to 8. Yeah. The questions will be like this. They are going to mix differentiation with integration. Some of these differentiation stuff with some integration. So you cannot like everything integration. No, it depends on the question. So you must see what you have information, then how do you use the information. Yeah. So this is part 1. Go to part 2. Part 2. Find the coordinates of the point at which the curve meets the y-axis. In order to find the coordinates, we need to find the equation of the curve. Yeah, that's the main thing, right? We need to know the equation of the curve. So to get the equation of the curve, we get it from the gradient function. So this question is very dangerous, because if you cannot get part 1, you're done. You are finished. Okay, you cannot continue part 2. Yeah. So we are going to find y. Find y first. So we do integration to reverse the right? Yeah. Then in this case, you'll get 4x 1 plus 1 over 1 plus 1 plus 8x and plus c. So the c comes in now. Then we have 2x squared plus 8x plus c. Yeah, so far so good. Yeah, then we find c. How to find c?
Sub the values.
Yeah, sub in -2, -1, right? Okay, sub in. This point can be used again because it's not only the turning point, but also a point on the curve. So we can use the point -2, -1 again. Then we find c. Yeah, so c gives us -1 plus 16 minus 8. 7. So we move to the other side. Therefore, the equation is y equal to 2y squared plus 8x plus 7. And we are done. Why? Because the question is asking the question, find the coordinates at which the curve meets the y-axis, meets the y-intercept. Y-intercept, not other points. So this is the y-intercept. Okay, therefore, the answer is 0, 7. 0, 7. Get it? So it's like not a lot of working. Unless you can do that, you can also say sub x equal to 0. You can find y also. And also can, without knowing that, oh, this is y-intercept. Okay? Can yeah. Let's move on. Then you only have one piece of homework to do. Oh, okay. Here, number 3. A curve has a maximum point and its gradient at any point xy is 6 minus 2x. What does that mean? Okay, find the equation of the curve. Yeah, again, let's find out why is it an integration problem. Why is it integration? So we start off from information. Information we have is there's a maximum point at 311. Okay, this is the information. One more, gradient at any point xy is 6 minus 2x. So this tells us this is the gradient function. It just described in a very sophisticated way. So it's just a gradient function, the most general function, okay, for gradient. So find equation of the curve. Yeah, try and see whether you can find equation of the curve. Familiar, got it? Then, Sarah, Phoebe,
Yeah.
Samantha,
Still doing.
Phoebe, finish ah?
Yeah.
Are you sure?
Yeah.
Okay. Homework is this, huh? Homework. You can do a bit here. Okay, I better make it. Okay. Samantha side. Wow. This one, we have equal to 0. No, no. What you integrate? Not finding K. Find Y. We do this. Yeah, you get this one. Then after that, you sub in okay. This is number 3. Right? You all did it, have we? Can you just do it directly. You find what's the maximum point for? Okay, I think this is a partial question. There are some other parts. It's not there. It's just one part of the question. Okay. Number 4. I just go through the number 4, the initial part. Then you all do finish up the question. Okay, as your homework. Then the next lesson, will be we're going to do integration of this type. You'll find, can I integrate such terms? Yeah, can. We can do that. Okay, so next lesson we will learn how to integrate such things. Okay, so for now, we are going to look at question 4 a little bit. Yeah, by the way, integration is like differentiation. We are going to learn how to integrate trigo, exponential, all these things. So all these things will come back. And application of integration. Luckily, integration application only got 2. Yeah, one is there are 2 of them. Next time we talk about it. Okay, now we have this part, dy dx. To kickstart the number 4, it's a homework. So Sarah, you take note of the homework.
Yeah.
Okay. You got a question ready? I mean, good. So you have this part, and then you have to find A and B. To find A and B, you need 2 pieces of information. Okay, because got 2 unknowns. So first one is you have to integrate. Okay, so you integrate. Okay, when you do your integration, you will get this line. So this is your y. Yeah, so you'll need this equation, which is central to many of the things you're going to do. Yeah. So when you have this equation, you'll find I have 3 unknowns. Instead of 2, now I have a burden. I have an extra burden, got a C. Okay. So to find the C, A, and the B, you have to use the information given here. Stationary points 1, 0, -3, -2. Yeah. So so you manage your job here. Yeah, to find A, B, and C. For example, how to find how to use the stationary point. So to use the stationary point, we use this information. Okay, but you find that if you are using 1 0, into your dy dx, you get 0 equal to 3 1 a 1 plus b. So you actually get one equation. Okay, so you do in this way. Then you sub in another point, -3, -3, -3 and 32. You get okay, then you get 0 equal to 3 of -3 square plus a of -3 plus b. Then you get another equation, maybe something like 27 minus 3a plus b equal to 0, something like that. So you get two equations and so on. So try to finish it as well. Okay, and this is your homework. Yeah, so the two homeworks that I gave you are this homework. Okay, I just here right here. So homework one is this. This is the rate of change. Then the other one is this work on integration. Yeah, these two questions. Okay, then let me condense the version of the notes. Then I will send you maybe tonight or what on the next part of the integration. Then you can read a bit if you want. Okay, then that will be our next lesson. Still on integration. Yes.
Why do you substitute it into the gradient rather than the equation?
Oh, because if I do that, right, I will have less complicated stuff to solve. Okay, you see, when we solve problem, is we don't want to create more problems. So this equation, okay, I use a highlighter. Highlight this equation. The mark is got another unknown c. Okay, if I sub in the points to the unknown, the equation of y, then I have more equations, more unknowns to solve. But if I solve it into the dy dx, I have fewer unknowns. I can solve like control. I only can solve a and b here first.
Oh, okay.
You get something like that. Okay, we try not to create a big problem, and then we're going to sub into the equation of the y, and then it has a, b, and c all together facing you. Okay, yeah. So the objective is to find a simpler path to solve our problem first, as much as we can. Yeah, can. So that's all for today lah. Okay. So I unmute Samantha's part. Yeah. So next lesson we will continue integration. Tonight I will send you a copy. Then for Sarah, okay, I will have to remember to send to your mom. Okay, because you don't have access to the phone. Okay, so that's all for
I
today.
took a photo lah, so.
Oh, the next part of the note. Next part of the note.
Oh, okay.
Can yeah. So I see you next lesson. Bye. Bye. Yeah. Bye. Bye. Hey.
Bye. I don't know how to go out. Wait, how?
Click the cross button on the top right corner.
Oh, okay. Bye.